Buongiorno, mi chiamo Vinícius. È davvero un grande piacere essere qui in mia prima volta in Bologna, in mia seconda volta in PyCon Italia. And that's as far as my Italian goes. The rest of this presentation is actually going to be... That was really hard because I'm trying to learn Italian. So if you didn't get my lousy Italian back there, my name is Vinícius Gubiani Ferreira. I am from Brazil. Yes, I came all the way from Brazil to be here. Tem brasileiro aí? Okay. 1, 2, 3, valeu, obrigado pela presença. I work for Asian Technologies, a Brazilian company. I am a tech manager, but I also been a QA team lead and a back-end Python Django developer for a while. I've been with Asian for around 7 years, 7-something months, years. That picture with the guy cutting grass with scissors is how I feel about quality. I am really annoying about quality. I like working on open source projects. The most amazing project that I work on is actually translating the Python documentation for Brazilian Portuguese. I also love craft beer, but the wine here in Italy is pretty amazing. And riding a bike around my town. I don't even own a bike myself. I rent it per year. So what's scheduled for today? We're going to talk about UV, of course. An open source tool, the new open source tool in the Python ecosystem, which is written in Rust, open source by a company called Astro. So we're going to discuss UV itself and compare it against other tools. Then we're going to see like the main commands of actually using UV to manage a project, and then package and publish a small application we're going to build and ship it to pyp.org. And then finally, to wrap it up, we're going to say some cases, discuss some cases when we should or should not actually use UV itself. So getting started, let's have a look into the Python ecosystem nowadays and in the past around 5-10 years. So I was actually going to use a different joke, but everybody is actually using it in this conference, so I decided to change it. You might have seen this before. This is actually how easy Python is, except it's not. And Python can be as complex as you like. Usually it tends to hide a lot of the complexity under the hood. But you can see there are a lot of things that are rather complicated in Python. For example, easy install has been pretty much dead for about 10 years when I joined the Python community. It's still mentioned in a lot of documentation for old Python packages. And Homebrew is something that I particularly never really liked Homebrew itself. And up to this date, I'm still trying to figure out why exactly they call it Cellar on macOS. It doesn't make sense for me, but my point is like Python can be as complex as you allow it to be. And usually there is like a tool for do a job, but unfortunately there are lots of tools that you need to put together to get things done with Python. So this is something that we'll see on the next couple slides. And this slide, it is not buggy, calm down. It is not also a color check for the projector. It is not also a color check for see who is colorblind over here. This is actually a Venn diagram to try to make the presentation slightly more interactive. Let's see how that actually works. So when we actually want to test a new Python package, hopefully, what is the first thing we usually do? And I'm saying hopefully because maybe you do in a different, unexpected way than what I'm actually hoping for as an answer over here. So can anybody help me out? What is the first thing you usually do when testing out a new Python package? Any guess? Sorry? Perfect, great answer. 1 point for you. So usually for that we have like virtualenv and venv into actually creating a virtual environment for not messing up your whole operating system and installing things that actually belong from one project to another project. Don't get confused, install a different package versions, don't do a big mess, keep it self-contained. And what's next? We're going clockwise. And what is the next thing we usually do after creating a virtualenv? Perfect. We're doing great. We actually use a package manager, the standard one in this case, pip itself, and right there in the intersection, we actually have pipenv, which can actually manage Python packages and virtual environments. So after getting packages installed, your code is actually going to evolve. You're going to add features, do some code refactoring, fix bugs, documents, that kind of stuff. Your code will evolve step by step or take some time. And someday, probably, in your organization, in your working group, in your own head, maybe if you are a single developer, someone may actually come with some ideas such as this. I wonder what's going to happen if we try to run with a Julius Python version, which is the brand new thing. Nowadays, everybody's talking about Julius version of Python. Or it may actually come up with some other variation of it, such as, I wonder how about we actually try with PyPy, because everyone that seems to use PyPy is actually happier, more productive, happier, and faster, that kind of stuff. So those tips are important to actually get it working, get into the right direction, into what's the next circle. Now, somebody want to take a guess? What is the next circle? Perfect, that's about it. And installing a different Python version usually is a job for PyEnv or Conda, right there in intersection. Who here actually likes PyEnv and use PyEnv? You do? Good for you, because I never could actually get that thing working. It always had an operating system error. I just, be gone, and I use Docker or whatever, a different computer whatsoever. I never could get PyEnv to actually fully work for me. Good for you that you had a better experience than I did. And PyEnv is the tool that does just that for Python managing different Python versions. You probably may be thinking about other tools. I think it's obvious by now, but they may actually come up in some different intersections somewhere in the next two circles. And there are some intersections that doesn't actually have a specific tool that apply, but we'll get there if we're actually thinking on a different Python version. So now that we have our code working with different Python versions, we have features, fixes, documentation, what is the next thing? We want to share it with the world. We need to earn money, right? Because we're not doing this just for the fun. We can actually do it for the fun, but we also need money for living. So somebody want to take a guess? No? Otherwise, I'm just going to spill out. 3, 2, 1. That was kind of a bit before, like in the package manage. It is a good answer, but it's not the answer that I was hoping for. But thanks anyway. That is the next step. There is one part before, really close. I'm just going to give out this building the package, like packaging everything up, creating a bundle with wheel distribution and source distribution, get everything ready, and after that, we have set up tools, which is the tool that do just about that, getting everything packaged up. And on the next step, since you already gave the answer, I'm gonna just go ahead, like ship it, get ahead. And for that, we have, just for that tool, does just about that, Twine itself. And right there in this section, we have Fleet, S-Cons, if I pronounce correctly, Matrin, and finally, right there in the middle, we have Poetry, if anybody was actually thinking about Poetry, then Hatch, and finally, right there in the center, Rye, PDM, PyFlow. Somebody actually uses PyFlow. I read it online, but I never heard about anyone that actually uses. And finally, UV. I ran out of space, so I have to pull a hat in there to make a bit of, to make it fit. Like, so you can see that right there in the center, we have those tools, which is like, are like the Lord of the Rings, like a single tool to do everything. So this is the magic we're talking about. UV is a tool that does all of this instead of having just small, tiny tools for getting the job done. Somebody taking a picture? No, I saw some phones up. That's annoying, like you're taking a picture and it's gone. But I'll share the slides later, just in case anyone is actually interested. And now let's make a quick comparison to some of the tools side by side. It is not feasible to compare all the tools, otherwise the slides will go all the way, maybe go around, so it's not possible to compare all the tools. I just pick some of them. And UV against PEEP, against Poetry, and Conda. So regarding speed, UV is written in Rust, so that means it's actually pretty fast. Poetry and Conda, they are still fast, but not as fast as UV itself. And finally, PEEP is the oldest one and the slower one, so this actually loses this battle. Dependency resolution, all the tools except for PEEP do it in a parallel way. So when you have a lot of things to get installed, so the other ones are really fast, and PEEP unfortunately is the slow one because it does one by one until the end. virtual environments, pip, unfortunately, is not able to manage virtual environment by itself. It actually needs another tool, such as pipenv. The other one's doing all right. You can actually see how this is actually going. Like, pip is going to lose all of the battles over here. It's playing until the end, lose. I think the only battle that pip actually wins against the other tools is like simplicity, like the standard way of Python, like the PEP8. Keep things simple. That is the only thing that pip does it really, really well. It's like a txt file, and that's about it. Lock file support. Big surprise. Pip loses again. The other one, they all have lock file support. If you want like truly reproducible environments with lock file support, which is actually better than txt. A single standalone binary. In this case, a big surprise. I don't know about how many of you actually know, but you have a dependency, a really important dependency to install Poetry, which is having Python installed. If you try to install it without actually having Python, like on a Docker container, you need to install Python first, otherwise it's not actually going to work. The other ones, Conda and UV itself, they're self-contained applications, like you just hit a single command, or like in case you're on Windows or even macOS, I think, I don't try on macOS, double click, that's about it. It installed it, ready to go. And finally, the last one, it's about PEP 682 support. And you're probably thinking, what the hell is PEP 682? We're going to be discussing that about now. Couple of seconds for photos. Done? Done. 3, 2, 1. You can get the slides later, don't worry. I know, because it's annoying. I take photos and I lose them. So PEP 682. It's very simple, PEP, actually. It's about an alternative for virtual environments, like creating a Python local package directory. So it is a specific folder, which they named Dunder PyPackages directory. Works pretty much like the idea of node modules from JavaScript. Languages, they copy ideas from each other all the time, so it's fairly common. You don't actually get like a complete Python installation like you do on a virtual environment, just a folder, and you get your dependencies in there. It is managed implicitly. You don't need to do a thing, like the package that is actually implementing this PEP does it for you. But a big surprise that I found out when actually reading about this PEP was actually denied by the Python Steering Council. That was actually, I think, the first time I ever seen a PEP actually being denied and use it anyway. Big surprise for me. It was like a big branch into the Steering Council. Like some actually wanted, some did not. And Astro used it anyway. But the big risk that is involved over here, it can actually lead to unexpected conflicts and maintenance challenges, because you need to, it will be a third way to actually managing, knowing where you're actually using your Python package from, because you need to know if they are coming from the operating system, your virtual environment, wrong finger, your virtual environment, and now Dunder PyPackages. So as it says, like in the PEP8, there should be one way and only one way to do things, and we're looking at that is not completely true. And probably the places that will be really hard, like if you're actually building an IDE like Visual Studio Code or PyCharm, that will be real annoying. How the hell am I going to know where I should import this package from? This will be a mess, complete mess. Changing, 3, 2, 1. Sorry about that. And regarding speed, you're probably wondering, why UV is so damn fast? You actually see things online such as this saying, oh, UV speeded up our CI/CD by 5 times faster. Wow, that is great. And people actually saying, my package downloads are so much faster now. Those big LLMs, chunky packages that takes like, I don't know how many gigabytes to install, they're now fast. There are key secrets for UV actually doing that. First of all, it's actually written in Rust. Rust is an excellent language for actually doing I/O stuff on the Nectar, so that is a big factor. Also caching. UV likes to cache all the things. You know, like that joke that you say, you're working with Java, so you're pretty much downloading the whole internet. That is kind of the same thing with UV. If you're actually like briefing, then it's probably UV caching something around while you're doing other things. So UV serves a lot of cache from what he already downloaded once. It just moves it around to a Dunder PyPackage folder. And instead of actually copying it, making a copy, it makes links, symbolic links and hard links, which are actually faster than just copying it. So this is one of the key factors on why UV is so damn fast for actually managing things. A cool feature about UV also is about zero setup scripts. So you ever had that wonderful job you did? You created a perfect script, single file, solves the problem you're actually wanting to solve, and now it's about time to share it with the world, right? There's a problem spot. You use an external dependency, for example, requests. Who here does networking with just standalone Python, right? So most people actually use requests. And now you have a problem. You need to have a requirements.txt or a pyproject.ml, or maybe, if you're not into that, like a cool, perfect readme.md file for people actually knowing how to use your script. So that is a big problem. Not anymore with UV, because UV actually used PEP 623. And you're probably thinking, oh, great, another PEP. I'm going to sleep. And this is actually fairly simple. Like, it's just this block of code. We actually use it on top of your script file, and your dependencies are in there. And UV is actually capable of actually using that for installing your dependencies. You don't really need a requirements.txt, pyproject.ml, which is an external file. Just your single file, and that's about it. But Vinícius, I hate this thing that I can't remember it. That's me talking to myself. And I don't like it, so UV got us covered. It uses like 3 very simple commands, which I'm about to tell you. You just create your script file, step 1. Then you tell UV, please add this package to my script. And of course, remember to tell UV that is actually a script with the -- script. And finally, you just run it with UV run script. That's about it. Not anymore, no requirements.txt, pyproject.ml, nothing. No, not anymore. Very simple. All right, so let's start to manage the project itself. Let's talk about the main commands of UV. I misspelled my slide. If you ever saw any presentation of mine before, I'm actually going to use this website. I'm not the owner of it, I just really like it. It's a website that actually tells you if you should deploy today or not. It's very cool because it has an API, you can see at the bottom. No authentication, it's really easy to use. You just hit that endpoint. It's actually going to hit with you with a message saying if you should deploy it or not. Messages change a lot according to the day and the time of the week. So it's just for developing a very simple CLI application here. But before getting started, I noticed my computer was really old, not this one, the one I have back at home. And I checked out which Python version I had. I was actually surprised to figure out I was still stuck on Python 3.8, which is terrible. And I decided to upgrade it. Very simple, straightforward. I tell UV, install Python version 3.13. My computer is around 13, 14 years old, and it installed in under 10 seconds. I was actually really surprised by that, really fast. Told UV to also, for the newest projects, to use this Python version from now on. So starting a project from scratch, you use just this single line, UV init --app --package, and name it with a good name for your project, a unique name that doesn't exist on pyp.org. We're going to go back in that because I made a mistake in our that. Don't do my second mistake. Don't forget the --app tells UV this is actually an application, in our case a CLI application, and --package to get everything ready to be packaged later on, to be packed later on. And our code is very simple, straightforward. We're just going to open the dunder init file. Use the request library and just fetch the API, get the JSON response, get the message, print it to the screen. Very simple. What could possibly go wrong? I'm going to run the code, and what do you think is going to happen? It's going to run, of course, except not. It's going to fail because I forgot to actually tell UV that requests is now a dependency. Silly part of me, but it's also very easy to fix. Tell UV, please add the requests package to my project. And we try to run it again, run a few times, UV run, my project, give us some cool message like, let's do it, make me proud, this is the way, etc. All right, so to turn it into a CLI application, this is very simple. We're just going to open the pyproject.ml and rename it to a better name because I'm not going to the terminal to call my project. I want something cool like deploy today. That's about it. And now I'm going to actually fix my mistake that I made before because I used a name that actually already exists on pyp.org. So I had to rename the project, in 2 places and also rename a folder. And I also lowered the necessary Python version because I wanted to install system-wide on my operating system. All right, so about packaging and publishing. That's actually going to be really, really easy. It's been harder for me the first time I actually published a package on pyp.org. That's not the case nowadays. We're just going to hit one very single command, which is uv build. Takes a couple of seconds. It's actually going to build a tar.ez, which is our source code, and a wheel file, a compiled version for architecture and operating system. Then we're going to call go to pyp.org and get a token for actually uploading it, and call uv publish. UV is actually gonna ask you for your username. Don't fall for that, I did. It's been a while since I published anything. You need to inform Dunder token instead of that. And actually, when it asks for your password, just supply the token itself. Takes a couple more seconds, and it's actually gonna upload both of those files to pyp.org. After that, go anywhere on your operating system, and now I went back to standard way, not UV way. I created a virtual environment and installed the package on my machine, and ran it from the terminal, call it deploy today. It told me, go with the flow. Very nice, great success. It worked, on my machine at least. And now to wrap it up, some interesting point of attention when actually using UV itself, something that you should keep an eye on. Keep an eye on these situations, particularly if you have a legacy or a monolith project, like if you're doing stuff with Python 2.7, sorry about that, I'm still stuck on Python 2.7, or maybe even Python 3.6, 3.7, but mostly in the cases of monolith. Because in this particular case, you may have a dependency that is not really pinned down, and UV might try to install it in a different way than you're actually using it nowadays. So that may actually end up introducing some bug in your project, which I would not be happy to find out in tests or with your client directly. So for large projects, maybe it's not, or old projects, it's not maybe the best idea to migrate with UV. You have some compatibility with pip, but it may try to solve dependencies a different way. So keep an eye on that. Maybe try to avoid it. Not all Python flavors may actually be present everywhere. And what do I mean by that? For example, on this macOS computer, PyPy is actually available for installing. And I noticed on my Linux computer back at home, it wasn't. And this is actually because the Python versions that UV supply, they are pre-compiled for operating systems and architecture. So it's hard to have all the available options for every system and every architecture, some of them, but actually be missing. And this is also the secret on why UV actually install Python versions like this really quickly, because it's pre-built. If you're nerdy for performance, or you really need performance, maybe you have to go somewhere else, because the standard Python version installed by UV is slightly slower than the standard one by your operating system. It's roughly around 3%. But if you really need performance, they are probably already building Python from scratch by yourself, turning Python. So that might not actually be the biggest problem ever. Cache size. If you are in trouble for actually storage space in your computer, you may notice in the long run, in a year or plus, that UV is actually taking a lot of cache or storage on your computer, because as I mentioned, it likes to cache all the things. One of the key secrets for actually being really fast. But this is actually fairly simple, clean your cache once every 6 months or a year, something like that. You may actually run into corporate restrictions. For example, if you're not the admin, the sudo, or the owner of your own machine, you may go to your job, to work. You may open a ticket for, install UV on my machine, please. And they're going to say, nope. Oh, just like that. Because, yeah, pip does its job. It does really well. Do it. Just like that. So you may stumble into this situation. It happens on corporate world. And finally, the big one, big topic of discussions, UV Enterprise. So Astro is a company. It did an amazing job into listening to the community, gathering feedback, adding features, fixing bugs, etc. But in the end, it is a company. And company actually needs money for a living. So who's actually paying for this? I don't know, you don't know about this. Astro is actually sponsored by venture capital, so sometime in the future they will need money for actually making a living. So we're not sure how that's actually going to work in the future, so let's just hope they don't go in the same direction as some other companies did and piss off the community. I'm not sure if I'd actually allow it to mention as a name, so I'm mentioning really lower tones like Docker and Hedges. So just to be sure, because those companies kind of pissed off the community, they went in the wrong direction. So let's see how this is actually going to be fixed, like maybe a version of UV that has some bonus features which you have to pay for or something like that. Let's see how that actually goes. In case I actually want to go deeper into what I was using in this presentation, I always like to quote fonts. You can go for any of these links. There's a presentation by I think it's the CEO and CTO of Astro itself, which goes into a lot of more advanced things than I actually covered over here. It's a great topic. It's just the name, but there's links if you just click. It goes directly to YouTube. And there are so many cool presentations going on at the same time slot. So I want to thank you so much for actually coming to my presentation. Grazie mille, obrigado, thank you, merci. And if you want to reach out in me, you can do it in any of these ways. Probably the best way is through LinkedIn, but I can also answer on Telegram, eBay, etc. We have time for questions, right?
Yes.
Yeah? Okay.
This is the
questions. Thank you.
Okay. Thank you so much, Vinícius.
Thank you.
And so we have many questions.
Wow.
I don't know if this works. Can I have the microphone, please?
Would you like me to read the questions?
So the first question is, have you used UV together with poetry? My work projects use poetry, and I wonder if UV is compatible with what poetry puts in project.toml.
That's a good question. I didn't get a chance to use UV along with poetry. Maybe there was some compatibility in the future, because I know UV have compatibility. You can actually run pip directly if UV goes like UV pip install, something like that. I don't remember the exact command, but nowadays there's not a specific command like UV. Maybe you can actually do it like UVX poetry, but I think that'll be kind of an overkill, like to, I don't know, like to use poetry inside UV, but.
So let me share. I migrate some projects from poetry to UV. There is a project called poetry to UV.
Cool. Okay. Yeah. Poetry to UV, cool. Yeah, lots of things. Like that PEP, for example, 682. I think it's going to be a big mess.
Okay, thanks. So next question: standalone scripts. Is it possible to put UV in a shebang? Sorry, so we don't need to prefix it with UV run.
I think it is possible. Yeah. I never tried myself. I was thinking about that. I think it is possible, yes. Never tried myself, but I think it is. Yeah. Thank you for collaborating.
Okay, so, okay, someone, this is about bugs, I guess. Is it possible to install UV in devices like Raspberry Pi? And
probably, yeah, I think so. The full installation is something like URL and a bunch of other arguments and stuff. So it's probably working on the Raspberry Pi.
Okay, so parallel dep install. What happens if during setup for package A, which requires package B is actually required at install time? Bad practice, but still happens.
Could you get the question one more time, because I fully didn't get the question. I know there's a problem in there, but I fully didn't get it.
What happens if during setup for package A, so you're trying to install A, but installing A requires package B, and package B is actually required at install time? It's a bit of a brain thing. If you want to read it.
No. I got the idea. Just thinking. But, I don't know if I got a case like this with UV itself, but usually packets required during install time are probably going to be like, for example, C modules that you need to compile, something like that. Those might be a corner case. UV dependency resolution is great. You can actually see the last link that I showed. It's going to go into much details into how UV actually solve dependencies. I think it works by like UV trying to solve this dependency, but never came up with this case myself. I have to check it on.
Yeah, food for thought. And I think we have time for a last question. So how does UV manage a mix between internal company registry and the official PyPy?
You mean an internal registry, right?
It says internal company registry.
Yeah. Private. Yeah, got it. There's an argument that you pass. I don't know the complete argument right now. It's something like -- private Apple, and you pass another argument with the address from where it could actually fetch the packages that are available inside your company. It's the same idea behind pip and poetry, which you need to supply where you should an alternative source, because it will actually try to find the package on pyp.org. In case it fails, it will go to the other addresses to actually try to find it. So it's an argument that you have to pass when installing the package to try to install everything they actually need.
Okay, thank you. And maybe we can go over and so last one. Can UV work with on-premise repositories for Python? Can I mirror some version locally?
You mean like mirror a version from pyp.org? Could you go again with the question?
So can UV work with on-premise repositories for Python? And can I mirror some versions locally?
I think you can. I'm just not sure if UV is actually going to solve first for your mirrored version or pyp.org. I must say I have a doubt about that, if it's actually going to try to hit pyp.org first or your local repository. I mean, doubt about that, but it's probably going to work. It's very close to the previous questions, like you can use a local repository instead of the official pyp.org. But it's doable. I'm not sure if just which order it actually solves. It's first pyp.org or first the private one.
Okay, thank you very much. Our time is up, but